Okay, so previously we had set out a bull spread, and bull spreads are a relatively standard type trading strategy used by traders. So it's a combination of two call options, a long call option, a short call option. Here we had the long position, which was had a lower exercise price, and then we had the short call. Again, the parameter values are the same in each case. The only difference is in terms of the exercise. So we are looking here to see what is the connection between the bull spread and a binary cash for nothing. So binary option. What is the relationship between the bull spread and the binary? It doesn't involve much, but we can introduce a few tweaks here that replicates or mimics at least the behavior of the binary option by making some adjustments here to the bull spread. So in our bull spread, which we previously illustrated on some video clips that I will leave a link to, actually the link is here, part 1 and part 2, and also on Vinegar. We estimated, we set up the long call and the short call, and we took the combination of the two, which is this green payoff structure. So in other words, what we typically get here is we gain as the stock price goes up, thus the idea of a bull spread, right? Just the idea of the bull spread, okay? In the event of the stock pricing falling below a given level, we are bounded here. At the same time, also if the stock price goes above a certain critical level here, 100, we're also bounded. So between 50 and 100, the respective strikes on the long call and the short call, where the options in every material respect are the same except for the exercise, we gain as the stock price goes up, but then there's a boundary in terms of our losses, and that's linked here at 50. So once we go below 50, we don't suffer any further losses. Once we go above 100, we don't gain any additional gain. So that's a bull spread, okay? Now, we also had set out payoffs in the usual way, the maximum of S minus X for the long call, and then again, the maximum for the short call, it was the maximum of S minus K, but to reverse the position, to go from long to short, we just make it negative, right? And that's what gives us this blue payoff here, right? And the long payoff is this one, where that is the maximum of S minus K, and then we subtracted away the premium estimated using the Black-Scholes model. And when we took the combination of the long call and the short put, we got this 37.34. So if we subtract 509 from the 42.44, we got the 37.34. Okay, so that's our bull spread, combination of the two. Now, how do we make this look and appear like the binary option? Is there a way we can tweak our bull spread so that it replicates the binary payoff? Okay, a couple of things we could do. First of all, perhaps we might note in a previous video, we had estimated a cash or nothing call option, and with these parameter values, the value, Black-Scholes value was 1045, with a cash amount of 100 on the cash or nothing option, it was 53.23. So we're going to look and see, can we replicate the payoff structure that we have here using the bull? and how might we go about doing that. Okay, so we started with the bull strategy, and to set up the binary, we need just make one or two small adjustments. First of all, we should make the exercise price for both the long call and short call as close as possible. Okay, so we could say, let's make this exercise 99.99 for the long call. And then for the short call, just a little bit higher, 100.01. Okay, so now we've changed fairly dramatically the payoff structure here. It looks like a flat line. For all intents and purposes here, it is. The payoff structure, if we look at the numbers from before, let's just change back. A couple of changes I introduced. If we go back to the previous spreadsheet where we had originally set up the bull strategy, when we look at the payoff here, it is the long call position, and then we add to that the short call position, right? So the numbers here, the payoff here is the same as what we have here. We do make one little change here, and just basically in terms of the numbers here went up in intervals of 10. We went up to 180. Likewise here, we went up in intervals of 10, but as we approached 100, we became more granular. And thereafter then back to 10, 120, 140, and in this case, we went up to 200. So in every other respect, this is the same. Okay, to replicate or to mimic the behavior of the binary option, we want to see if we can mimic the payoff, the cost of setting up the strategy, the premium, and then the payoff that we have here. Okay, so a couple of things then. We changed this to the 99 to get the exercises as close as possible to each other. And that will create basically, we get what looks like a straight line. Before, we just added the long position and the short position together, and we got a result of previously a number that was higher than this when we used 50 and 100 here. What we didn't do before was we didn't multiply by a multiple. And in this case, we're going to multiply by 5,000. Okay. And then once you multiply by 5,000, then you can see that we amplify the payoff on the bull spread portfolio, or the bull spread strategy. So now we've gone from one long call and one short call to, in fact, 5,000 long calls and 5,000 short calls combined together. And the payoff here with 90, if we change this to 90 here, let's take a look. 90, we get a value using the Reiner and Rubinstein cash or nothing implementation. The cost of setting up the strategy is 33.59, so 33.59, and we would win in the event of the option being in the money at expiry. We would get a payoff of 64.40. So basically a payoff of 100. That's the cash amount. And then when we subtract the cost of the premium, 33.59, that would leave us with 64.40 for the cash or nothing option. When we go back here to our bull spread strategy, we can see we're getting the same results here, 33.59, 33.59, and we can see also that in the event of the option being in the money, we get a payoff net of the premium of 100, but nets to 64.40, right? And that's what we would have observed here also. Again, we're using Reiner and Rubinstein here. In this instance, right, we're using this formula, using this function, Here we're using Black-Scholes, the combination of Black-Scholes. So Black-Scholes. We can test that a little bit. Let's change this to 100. Right. And when we change to 100, we can see here that the cost of setting up the portfolio is 53.23, 53.23. And in the event of the option being in the money, we have 46.76, 46.76. Let's have a look at the binary. 33, so we'll change this to 100. Using Reiner and Rubenstein, cost of setting up the strategy, 53.23. What do we gain if the option is in the money? 46.70, 46.76. That's this amount here, 46.76. Let's check here with the bull strategy, 46.76. Maybe one more, 110. Payoff here, the cost of setting up the strategy is 69.87. Change this to 110, 69.87 using Reiner and Rubenstein. How much do we stand to gain if the option ends up in the money? 30.12. Let's go back, check. Here, 13.30, but I'm sure if we adjust for round to the next decimal place, we get a bit closer. No, so it's 13.30, but approximately the same. Okay, again, if we 12.99 is approximately 13, right? And we can change the volatility perhaps. Let's change this to 0.3. We can look at the numbers here. We can go back to the binary option, change this to 0.3. Right? What do we find? We're getting the same numbers as the binary cash for nothing. Okay, now the last question that remains here, which I haven't really addressed, is, well, why 5,000? And it is 5,000 simply because if we take the product, remember the cash amount, we didn't specify here a cash amount, but the cash amount has to equate to 100. So we take the difference in the two exercise, which is 0.2. What multiplied by 0.02 gives us the cash amount that we would have seen with the cash or nothing call option. It was 100. 5,000 times 0.02 gives us that 100. So that's why we put in 5,000. If we don't put in that 5,000, then our numbers don't really work here. It has to be 5,000. If the cash amount was smaller, then we would have, if it was 1,000, then if the cash amount was, let's say 200, then we would need 10,000 here. If the cash amount was 200, we would need 10,000. Let's just check that. Let's change this to, okay, let's go to the cash or nothing. Change this to 200. Okay, the payoff in the event, if the we're in the money is 200, but you've got to net out the cost of setting up the strategy, 120. That leaves us with 80 or 79.96. Okay, 79.96 if we are in the money. Let's just consider that in this instance here. If we wanted to replicate the 200, then we need to put in 10,000 here. So that's 10,000. And you can see we're getting the same numbers. So scaling it by the right amount is, how do we set up the bull spread so that it replicates the cash or nothing? We have to ensure that the scaling amount here, what we multiply the portfolio by, the amount of the cost of the premiums under different circumstances, that must be consistent, that we get the cash amount that we're looking for in this case. So it's 10,000. So 10,000 by the 0.02 will give us 200. And that's something, cache, that is a parameter that we must include in the Reiner and Rubenstein 1991 formula. Okay. Okay, one small point here. Why is this relevant? It's relevant in particular if we, for instance, if we can replicate the binary option using a bull spread, right? If we can do that, and we ban binary options, but we allow bull spreads to trade. Bull spreads are made up with vanilla options, so they're perfectly legal to trade. Then theoretically, we're not consistent. If we look at the range of measures introduced in recent years, in recent months, in fact, by the ESMA and by the FCA and a whole host of regulators throughout Europe, Australia, so on. If you ban the distribution sale of binary options, but you leave bull spreads and they are allowed to trade and be sold and distributed, then the difficulty is this is not theoretically consistent. And that poses problems then perhaps that you open the door to regulatory arbitrage. So some of the measures introduced by ESMA, the Financial Conduct Authority, by other regulators throughout Europe have inherent difficulties, and I'm not sure how those can be easily reconciled, right? Part of the problem, of course, is you have a lot of fraud related to OTC binary option trading where the brokers are unlicensed. The solution presented by regulators is to ban the binary options. It may make more sense to go after the fraudsters as opposed to going after the financial instrument. That may be difficult when many of those fraudsters are not within the jurisdiction of a given regulator. And by and large, regulators have simply responded in a manner where they ban the financial instrument. In fact, I think what they've got to do is pursue the fraudsters. And that's a real difficulty, right? And I don't have a solution for that.